Yeah, okay. So let's do this. Ammonium iodide. Now, what do we know about any ammonium solid? One thing that we need to know is that ammonium salts are acidic. So it's a white solid which decomposes when heated, all right. A small sample of ammonium iodide is heated in a test tube. What kind of a reaction is this? This is decomposition. Why? Because you're breaking one thing and making multiple things from it. So that's decomposition reaction. Because it's being heated, we'll say that this is thermal decomposition, although they seldom ask us for that. All right, a small sample of ammonium iodide is here. Describe how you would know when all the ammonium iodide has decomposed. So looking at the equation is really, really important. You know that on the left side you have solid and on the right side you have gases. So because you're heating it up, you will simply say that we will know that all of it has decomposed when there are no more fumes coming up. Another way to say that is that we will know when all of the solid has disappeared. Okay. So once we know that, that will tell us that none of it is left over. Calculate the volume of gas measured at room temperature and pressure formed when 2.9 grams of ammonium iodide is completely decomposed. So on the left side, we have ammonium iodide. So I'll just copy that part, ammonium iodide. There's one relative mole is 1. And we want to figure out volume of gas. Now you notice that there is 1 mole of gas here and 1 mole of gas here. So basically there is double the gas produced. That's it. In terms of moles, this is double the volume. Okay, now if I have 1 mole of this, and what do I have for this? I have mass. So I will figure out the MR. So MR of ammonium iodide will be 14 for nitrogen, 4 for those 4 hydrogen. And for iodine, if I'm not wrong, it's 127. I'll defer to somebody with a periodic table. Yeah, so it is 127. So if you add all of this up, I think we will get 145. So that is the mass of 1 mole of this thing. So 1 mole of this thing produces 2 moles of gas. And what's the volume of that gas? 24 for 1 mole. So 2 times 24 for the total. You have 2.9 of this. So you will get X moles of that. So when you cross multiply this, you are comparing mass with volume. So obviously, when you do that, this is what we'll get. So X equals 2 times 24 times 2.9 divided by 145. Now, if somebody doesn't like this method or they're not comfortable with this method, then we have the traditional method, which is that because you are starting off with mass of ammonium iodide, you first find number of moles. So number of moles of ammonium iodide is going to be mass divided by MR, and MR is 145. So you do that, you will get a certain number. Let me just call that K. Okay, I don't have a calculator. Now, once you have that, you will figure out that, okay, how many moles of gas is being produced? It's 2 moles, right? So if 1 mole produces 2, K moles will produce X, and X comes out to be 2 times K. K is that number. You can use a calculator to figure that out. Now you have 2K moles of gas that's going out. So what's the volume? Volume of 1 mole, or if you want to use the formula, volume over 24 is number of moles. So I'll put that here, and that means I'm getting 48K. K is whatever the number was. dm cube of the gas. All right. Describe a chemical test for iodide ion. Now the test for any halide ion is the same. You add silver nitrate. Now here's the thing. What if you're adding it and there's already some carbonate ion present? So it's possible that silver will react with carbonate. So that is why what we do is we add dilute acid, then silver nitrate. And what acid is the best one for this? Nitric acid. Why? Because you're adding nitrate. So the full answer will be add dilute nitric acid followed by silver nitrate solution. Now what will you see? For halides, silver provides precipitates. So the precipitate is white for chloride, off-white for bromide, and yellow for iodide. So your observation is that you will see a yellow solid. All right. Aqueous ammonium iodide reacts with aqueous bromine. Now, what is this reaction? This is about displacement. Now, you know that in the non-metals, the higher up anything is, the more reactive it is. The reason for that, it's really simple. Smaller atoms gain electrons faster than larger atoms. That is because the nucleus can easily attract that electron. So bromine, for example, is a smaller atom than iodine. So when it wants to gain electrons, bromine wins because it does it faster than iodine can. So we'll say that this is ammonium iodide which is going to react with bromine. Now, an important thing to remember here is that bromine exists as Br2. This is a diatomic element, and there's an inverted L in the periodic table where you start with oxygen, nitrogen, fluorine, and all the way to astatine. These are all diatomic gases. And then we have hydrogen, and hydrogen is also a diatomic gas. So these 8 gases are all diatomic, okay? So Br2, it forms NH4Br. Why? Because this Br is going to displace. This is a displacement reaction. Many different names for this. This is displacement reaction. This is also redox reaction, okay? Because this is bromine is reducing and iodide is oxidized, all of that. Okay, so NH4Br plus I2. Iodine again is going to exist as a diatomic molecule, so we'll balance it out. So 2 here, and it's balanced. So that's the equation that we have to give. Now they're also asking us for state symbols, and this is not just a chemical equation that they've asked us. They've actually asked us for an ionic equation. Okay, so how do we write the ionic equation for this thing? I'm sorry for all this mess. Yeah, so for ionic equation, what you have to understand is that first write all the uh, states. So this one, it is solid, and this one is aqueous, and this one is again aqueous because you're going to dissolve. All ammonium salts dissolve, and this is going to be solid because at room temperature this thing is solid, but if you're added in water it will dissolve as well. So aqueous or solid, both are acceptable. Now what will happen? Anything that is going to react, you ionize it. So ammonium is going to ionize and you will get ammonium positive. You can also say that this is aqueous, reason that it will dissolve in water once you add it, plus iodide plus Br2, which is just a molecule, it won't ionize. And this thing on this side, you have ammonium ion and you have bromide ion and you have iodine, which is again a molecule that did not ionize. So you can see that ammonium is a spectator. Why? Because it did not react. It did not change. No chemical change was seen when ammonium did that. So you'll simply balance it out now, and there you go. That is your ionic equation. Based on this, we can see that iodine basically lost electrons. So iodide lost electrons to make iodine, and bromine gained electrons to make bromide ion. All right, solid ammonium iodide does not conduct electricity. Okay, so ammonium iodide, obviously, it doesn't come as a surprise to us. It doesn't conduct electricity because it doesn't have any free ions, right? It's ionic compound. And next thing is aqueous ammonium iodide does conduct electricity because it's dissolved in water. No wonder. Why is that? That is because ammonium iodide, when you dissolve it in water, it ionizes. So solid ammonium iodide, you can write this formula if you want, doesn't have free ions. That is it. That is the reason that they're not able to move. Now, one thing is important. Do not mention electrons here because electrons are not responsible for conduction in either of these states. It is the ions. And aqueous ammonium iodide, you can write just AQ if you want. You don't have to write the whole aqueous thing. That has free ions, so they conduct electricity. And there you go. That's our answer. All right. You can also say that they are not, instead of saying that they are not free, you can also say that they do not move, or something that has the same meaning. Nitrogen monoxide reacts with oxygen to form nitrogen dioxide. About these oxides, what you need to know is that first, nitrogen monoxide is neutral, nitrogen dioxide is acidic. Nitrogen dioxide is brown. Another important fact to remember is that they are formed when there is lighting activity, because at high temperature, nitrogen and oxygen in the air react together. Same thing happens in car engines or any internal combustion engine, because the air's nitrogen from air and oxygen from the air, they react together at high temperature or the severe conditions that they have in car engines. Okay, so they produce this. This is called fixing of nitrogen or nitrogen fixing. All right, this is an equilibrium, dynamic equilibrium. They sometimes ask you to define dynamic equilibrium. So just remember that it is when the rate of forward reaction is the same as the rate of backward reaction. The rate word is really important there. All right, explain why it is important to have a closed system to establish a dynamic equilibrium. The thing is, if you don't have a closed system, what's going to happen? The reactants and products, whatever you have in there, they will escape. Simple. You want them to remain in some vessel, but they're going to go out. So if there is an outlet, they're going to escape out of it. So you don't want that. There is never going to be an equilibrium in that condition. So there's a very good animation on this. I will share that with you on the group. So why is it important? Because we do not want reactants or products to escape. So just mention that. Pressure of the equilibrium mixture is decreased. Now, whenever the word pressure comes, that's our hint to look at the number of moles of gas. So on this side, we have 3. On this side, we have 2. So just remember that. Temperature of the equilibrium is kept constant. So temperature is constant. That's all right. It's not going to affect it. Predict and explain what will happen, if anything, to the composition of the equilibrium mixture. When they say, you see the word composition is bold, that is because you have to pay particular attention to what is in it, the reactants and products, and you should refer those in your answer. Okay, so first of all, let's see how the equilibrium will change. If you have higher pressure, the things that are greater in number will collide more per unit time. So the reaction will be faster for those. So if you had higher temperature, the things that have 3 moles on the left side, you can see reactants, they will collide more per unit time, they will react more, or they will react faster, and they will drive the equilibrium forward. What you're doing here is that you're decreasing the pressure. What that does is it pushes the equilibrium backwards. Why? Because the things with less gaseous moles, they are going to react more. Okay, so if you decrease the temperature, then what's going to happen is that there is going to be a decrease in the amount of product here. So prediction is that there is less number of moles, or less concentration, or less amount, or less number of molecules of nitrogen dioxide. That's my prediction. Or you can also say that there's going to be more reactants made, or more NO and O2 made. And why is that? The reason is simple. There is more gaseous moles on the left side, or less number of gaseous moles. The word gaseous is really important in this. Moles on the left side, on the right side. So equilibrium moves backwards. Why exactly does that happen, or what's happening at the particle level? The explanation isn't really required at this stage. So we just go with that. Gaseous moles is really important. If you just mention moles, you won't get any marks. All right. Moving on. The temperature of the mixture is decreased. So they're decreasing the temperature. The pressure is kept constant. Okay, so now the pressure is the constant one and temperature is decreased. We do not know whether this is exothermic or endothermic, but what we do know is that temperature is decreased, which means particles have less kinetic energy. Okay, so that's why the position of equilibrium moves to the right. So, okay, so this is telling me that it has moved to the right. I decrease temperature, the reaction equilibrium tries to undo that change, so it goes forward, which means on this side temperature will increase. So why is that? It is because the reaction is exothermic. Okay, so you can say that when it goes in the forward reaction, temperature increases, or when it goes in the forward reaction, that is exothermic. So you can say that exothermic forward reaction is, sorry, I'm never good with spellings. Forward reaction is exothermic. Next is explain why the rate of reaction decreases. Okay, so when you decrease the temperature, it doesn't have anything to do with the equilibrium, by the way. When you decrease the temperature, you have basically reduced the kinetic energy. The average kinetic energy of particles is directly related to the temperature. So if you decrease the temperature, the average kinetic energy will also go down. And now particles move slower. They collide slower per unit time, or there are less frequent collisions per unit time. Another important reason is that they might not have more particles, less particles now have enough energy to react. You remember that activation energy? So if you decrease the temperature, less particles will have enough energy to react. So now the rate obviously decreases. Okay, so that is because average kinetic energy of molecules has decreased. So less number of successful collisions or collisions. I don't know the spelling for collision, so I think there's a double L here. Per unit time, that's very important. Okay, per unit time, because you're talking about rate. Rate अकेला collisions पे नहीं depend करता, वो time पे भी depend करता है. So less number of successful collisions per unit time, obviously rate. Draw a dot and cross diagram for a molecule of oxygen. Pretty simple. All you have to do is put an oxygen here, okay, and another oxygen here somewhere. So another oxygen, and then just drop O here, O here. They are sharing 2 electrons, so 2 electrons each. This has 4 left over. This also has 2 left over here and 2 left over here. And that is the uh, outer shell. Now, because they have mentioned that you only include the outer shell, I haven't drawn the inner ones. If I wanted to, I would simply put this here if I needed to, but make sure you do not circle the nucleus. That's not required. We don't really need this, so I'm just going to leave this one out. But you don't have to draw a circle for nucleus. For example, if this was sodium, do not circle this like that. The examiner might think you're drawn another shell, so don't do that. All right. Nitrogen dioxide reacts with water, that is reacting with water to form nitric acid and nitrous acid. You do not need to remember the formula for nitrous acid, but for nitric acid, you should know. Construct an equation for this reaction. Now, they haven't explicitly asked us to balance it, but you should balance it. You must balance it, okay? So maybe just put 2 here, and yeah, that might not work for us because we need multiple hydrogens. So this might take a while, but let's see if we can do it. So if I put 2 here for nitrogen, nitrogen is balanced. Hydrogen, there's 2 of it. So hydrogen here, that's also balanced. And oxygen, there's 4 oxygen here, 1 here. So that's 5. And then 3 here and 2 here. Oh, it is balanced. So one important thing to remember for balancing equation is always start with any other element, then do hydrogen, then do oxygen. Now, this is not a rule in particular. There are instances where we avoid this, but in most cases, this works. Similarly, when you're balancing, try to balance the particles involved. So for example, in this case, atoms were coming and going and all that. It wasn't primarily an ionic reaction, so I did not balance ion. I balanced atoms. If it was an ionic reaction, I would most probably be balancing ions. All right, nitric acid is strong acid and nitrous acid is a weak acid. So this is a 2-mark question, okay? There are 2 things that you have to determine here. First of all, the simple difference is, the simple answer would be now that nitric acid, so nitric acid uh, ionizes fully. And if you say that, you will get 1 mark. Why? Because you had to mention what happens, what is different in nitrous acid. So mention that as well, that nitrous acid ionizes partially. Do mention that. Do not leave that one out. Now, some students, I can expect them to answer that it gives H positive ions. Now, the thing is, it's not really required because they haven't asked us to define what an acid is. They've just asked us to find the difference between strong and weak acids. Okay. So yes, Alina, your answer is right. Zen, I just saw your answer, your question. What was the question about the colors? What colors?
Say it was a question about the ion. It has the colors question. It was part C of some question. I don't remember what question.
Okay, I'll go back to that at the end of the lesson, so we can revise it then. If you have a question, I'll clear this one. Okay, this is too fast for me. All right. Organic. What's happening here? They've drawn a polymer and they've told us it's an addition polymer. We have studied that addition reaction is possible in unsaturated compounds, which means there must be a double bond that they broke. So let's look at the basic thing. So C, C, this repeat unit, just copy that one here. And now just add a double bond. This broke here, so just add a double bond here. Remember, whenever addition reaction occurs, the carbons involved get something connected to them. So obviously this is connected on the left side, this is connected on the right side. So that means they must be connected with each other before this actually happens. So you can just put N here to balance this N, and there you go. You have N of this thing. This thing is vinyl chloride or chloroethene, and it forms chloroethane, uh, polychloroethene. They have already told us what that is, so it's in parentheses so we can easily identify it. All right, so we have to balance this one out. So we have the empirical formula. Why empirical formula? Because that is telling us about the basic ratio in the polymer. We can't really count, like we can, but we don't have to, how many atoms are there. So let's see. There are 2 carbons here, so most probably 2 carbon dioxide, 3 hydrogens, 3 by 2, sorry, 3 hydrogens, so that is 2 here and 1 there, so that's 3 hydrogens, and chlorine is also balanced. Oxygen, let's see, 2 here, 2 times 2, 4, 4 plus 1, 5. So 5 there and 2 here, so 5 over 2. Remember, balancing is all about ratio. I have 5 on the right side, I have 2 on the left side, so I'll just write 5 over 2. There you go. This is pretty much balanced, but we have a bias for whole numbers. So I'll just multiply the whole thing by 2. So this times 2 is this times 2 is just 5, this times 2 is 4, 1 times 2 is 2, and 1 times 2 is 2 again. So it is balanced. If you left 5 by 2 there, you will not lose marks. Remember this thing, okay? You will not lose marks. That's perfectly fine. Suggest why the combustion of polychloroethene will contribute to formation of acid rain. Just look at the equation. It's forming carbon dioxide, steam, not that much of a problem, but this thing, alarming, HCl, this is the toxic fumes that we talk about when we burn polymers or when we talk about it. So HCl will dissolve in water, rainwater obviously, and it will cause acid rain. So you can simply say that HCl will dissolve in rainwater and cause acid rain. Okay. All right. Some waste plastics such as nylons are polyamides. Amide linkage, remember this is the amide linkage that we're talking about. Give one large scale use of nylon. जी बताएं nylon कहाँ use होता है? Clothes, ropes, those two come to my mind. So just put that. Yeah, Lena, you're right, clothes. Structure shows a monomer that can be used to make a polyamide. Interesting. We want to make polyamide. All right, draw the partial structure of the polyamide. So just notice where you have to join it from. So remember that polyamide simply means you want amide linkage. Amide linkage involves C double bond O on one side and NH on the other side. In other words, you basically have to just remove water. So there's OH from here that will remove and 1 hydrogen from here. So when that goes away, what am I left with? I just copied the whole thing. I'm just copying this without OH. And on this side, I have 1 hydrogen, 1 is left over. And that is my partial structure. So just put that in there. Is that good enough? If somebody did that, they will still lose a mark. Can you identify why? It is because they've asked us for 2 repeat units. So when there is 2 repeat units, you actually have to extend this. Make a copy of this whole thing. So copy of this whole thing, whatever you have here. So I'll start with the N, NH, then there's C, CH3 here, H there. Do not leave anyone out. So C double bond O, and then I can just put it there, and that's my partial structure complete. Copper waste is melted and then cooled to make new objects. Suddenly they've jumped from organic to inorganic. All right. In fact, this is physical chemistry, the question. Use the kinetic particle theory to describe the changes in movement and arrangement of the particles when a liquid cools to become a solid. So we have to use the kinetic particle theory. What did kinetic particle theory say? It said everything is made of particles. They're constantly moving. They have forces between them which are affected by the distances that they have. That's it. Those are the four main things about kinetic particle theory. So let's talk about those. So when a liquid cools to become a solid, that's the important bit. Liquid, what about the movement there? And what about the arrangement there? So in a liquid, what happens? Particles have moved freely. I've talked about the movement now. So they move freely, or you can also use the word slide over each other. And there's no fixed arrangement or no fixed order. Okay. And in a solid, particles have a fixed arrangement or regular arrangement and vibrate in place. And that's the transition. The transition that happens when it goes from liquid to solid. You can phrase it any way differently, but just make sure you refer movement in liquid, movement in solid, arrangement in liquid, and arrangement in solid, and that's good enough. Explain in terms of structure and bonding. Why copper has a high melting point? Okay, so what's the main difference? Why does copper have high melting point? It has strong forces of attraction between cations or layers of cations and free electrons, which are hard to overcome. So we need higher energy or high temperature. That's it. So we have referred to structure, we have referred to bonding. So we'll say that there are strong electrostatic force of attraction. There's strong force of attraction between layers of cations and free electrons. So I've talked about bonding, I've talked about structure, and now I'm mentioning why it has a high melting point. So you need high energy to overcome the forces. That's it. All right. So we have two substances here. One is an alcohol because it is OL and it has OH here. And one is an organic acid because it has OIC here and there's COOH that makes it that. Explain why cyclobutanol. Why is this a cyclobutanol? Because if you notice, this thing is a cycle. Okay, it forms a closed structure. When you have a closed loop in an organic compound, we say that it is cyclo. Okay, of course, they also usually have single bonds, but that's besides the point. Explain why cyclobutanol is not a hydrocarbon. Not a hydrocarbon because it has OH in it. So there is OH. So it has oxygen. Okay. If you want to explain it, you can say that while hydrocarbons only have carbon and hydrogen. That's good enough, although it wasn't really required. Explain why butanoic acid is a saturated compound. It's saturated because there is no double carbon-carbon bond. If you mention it doesn't have any double bond, you'll be wrong because you see this double bond here. So we'll say that it has all carbon-carbon bonds are single, and that's saturated compound. Describe a chemical test that can distinguish cyclobutanol from butanoic acid. Interesting. What are we doing here? We are trying to distinguish between alcohol and acid. This is a very interesting question because I haven't seen this question in the last year. What they're actually trying to determine is that what can you do to distinguish an alcohol from an acid? So it's pretty simple. What can we do? We know that alcohols can be oxidized. What is one property of alcohols that carboxylic acid cannot do? It cannot be oxidized. So we can say that add KMNO4 aqueous. With cyclobutanol, the thing will oxidize and then acid will produce. But what happens to KMNO4? It turns purple to colorless because it has reacted and oxidation has occurred. But there is no visible change or no change in color, or color remains purple. Okay, so that's one difference we can see. Another thing, what you can do is that you can maybe another important thing that you can do is, what is one reaction of acid that alcohol cannot do? So you can react alcohol with an acid. It will form an ester, but acid with an acid will not make an ester. So you can say that add cyclobutanol to maybe ethanoic acid, a sweet smelling compound is made, but it doesn't happen in butanoic acid because butanol and alcohol can convert to what we say ester, but with acid, but obviously acid and acid cannot. Another important way you can do this is that maybe add universal indicator or pH paper with solution of this thing. With butanol, it's going to be neutral, right? Because it's not acid. So you'll see the color is green. With butanoic acid, it's going to be maybe yellow or red. So just mention that, okay? So all of these things test whether this is acid or base or whatever. Another thing that you can do is that you can use the same esterification test, but with acid instead of with alcohol. You can say that take ethanol and react with butanoic acid, or maybe warm butanoic acid with alcohol, ethanol, and sweet smelling compound is made. But with butanol, it doesn't. So there you go. That's another way for us to remember this. All right. Calculate the percentage by mass of carbon in cyclobutanol. So percentage by mass of carbon in cyclobutanol. Let's look at the formula. There is 4 carbons and there is 8 hydrogen and 1 oxygen. So C4H7OH. All right. So carbon is 4 times 4 times 12. Sorry. Divided by the MR, which is 4 times 12 plus 8 times 1 plus 1 times 16. So you add it all up, 48 over, I don't know, 48 plus 8 plus 16, that is 48 over 72, that is 2 by 3, so 66.7%. Multiply by 100%, don't forget to do that. All right, ethanol can be converted into methyl ethanoate in a two-step process. What's happening here, that you are basically converting ethanol to methyl ethanoate, okay? And obviously this is an ester and this is an alcohol. What's the journey like? You have to first convert alcohol to carboxylic acid, and that carboxylic acid will then convert to ester. Why are we sure that this is the case? Because in the ester that we have, there is carboxylic acid with 2 carbons, and no wonder this is basically made from alcohol, ethanol. So what's compound X? The one that gives us ester with 2 carbons. It is ethanoic acid. What is used to convert this to this? KMnO4, because we want to oxidize this. What is used to convert carboxylic acid, ethanoic acid to ester? We will need an alcohol that provides this. What alcohol provides 1 carbon? Methanol. And there you go. And that is the section B of the paper. If you have any question, feel free to ask.